Welcome to you all to this MOOCs online video course Theory of Yarn Structure. We are going to continue with our discussion on module 8 tensile mechanics of yarns. In the last class we started with fiber orientation. We talked about fiber orientation, then also we continued with isotropic orientation of fibers. Then we started with anisotropic orientation of fibers. Today we will continue with anisotropic orientation of fibers. As I told you in the last class, we are going to model isotropic orientation to anisotropic orientation, this change. So, we will take this model with an idea of imaginary flexible belt equipped with spikes. These spikes will resemble the influence of surrounding fibers. So, this model is explained with this diagram. So, this resembles a flexible belt. These black circles, they resemble the spike. So, this is basically the starting position in this model, and this is the end position in this model. What we see is that there is a fiber segment. Starting point is 0, the end point is at P. So, this fiber segment is lying on the flexible belt equipped with spikes. So, this fiber segment makes an angle psi 0 from the y naught axis. So, tangent of this angle is equal to x naught by y naught. This is the starting position. Now, imaginatively we elongate this belt. This direction of this elongation is shown by these two arrows. As a result, what happens? The coordinates change, and also the inclination of these fibers which were staying onto the spikes also changes. Suppose now this fiber segment makes an angle psi from the y axis. This distance remains same at x naught. For that purpose we have taken some extra length, and another coordinate is y of this point. So, tangent of psi is equal to x naught by y, right. Now, the relative change along the ordinate. So, y by y naught, this ratio is greater than 1. This ratio we use a symbol which is equal to C, use this ratio. we will talk about the character of C a little later. Now, you consider this ratio is equal to capital C. Okay. Now, so these three equations now we will use. Let us write it one more time. Three equations. One, tangent of psi naught is equal to x naught by y, tangent of psi is x naught by y, and C is equal to y by y naught. These three are our given relations. Now, we start with tangent of psi, this second one, which is equal to x naught by y. What is x naught? X naught from first expression is equal to y naught into tan psi naught. Y naught by y is 1 by c. So, C, right. Now, if we now differentiate this with respect to psi naught, what we get? D psi is equal to d psi naught, right. So, d psi naught by d psi is equal to C sec square psi by sec square psi naught, right, which is equal to C tan square psi naught plus 1 into sec square psi is cos square psi. So, let us write here sec square psi, we need more space to write. So, C by cos square psi into 1 plus tan square psi naught. Tan square psi naught is C square tan square psi. How? From here, this indicates tan psi naught is equal to C into tan psi. So, we substitute here 1 plus C square tan square psi. Okay. Now, we will work more on this expression. D psi naught by d psi is equal to C by cos square psi plus C square sin square psi, which is equal to C cos square psi plus c square 1 minus cos square psi. So, c by c square minus c square minus 1 cos square psi, right. So, we obtain this expression. Now, we need to understand about this one. What is the physical meaning of this ratio? This we need to understand. So, we talk about 4 symbols. This symbol we have earlier used. What is the meaning of this symbol? This symbol means PDF of angle psi naught. So, this was related to starting position. Right. Then we have used another symbol. What is this? Probability density into class width, that is relative frequency. So, relative frequency of fiber segments in the elementary class of width d naught. This was related to starting position. So, what does this meaning? Let us draw. Suppose this is your x and this is your y. There is a band, suppose this band, suppose there are many fibers. So, this angle is your psi naught and this width is d psi naught, right. Okay. Now, we use 2 more symbols. One, f of psi PDF of angle psi. When it becomes angle psi, end position. And then what will be f psi d psi? This is the relative frequency of fiber segments in the elementary class. End position. What does this mean? Suppose we now have another band. All these segments will now change to their position. This angle is psi and this width is d psi. So, all these fibers which were lying in this class are now changed to a new position. So, as a result of this, relative frequencies must be same. Suppose there were 3 fibers, here also 3 fibers. So, the angular disposition changes, but relative frequency does not change. That means, relative frequency must be same. If relative frequency must be same, that means f psi into d psi is the relative frequency of this class is equal to f naught psi naught is into d psi naught relative frequency. So, these two relative frequencies must be same. So, we obtained now this relation f psi d psi is equal to f naught psi naught into d psi naught. So, what is your d psi naught to d psi? Psi naught, right. So, we substitute this expression into this expression. As a result, we obtained this. What is the value of this? Probability density function of isotropic orientation. We have already derived this value is equal to 1 by pi. So, f of psi is equal to 1 by pi c squared minus 1 into cos square psi. So, this expression characterizes the probability density function of anisotropic orientation. So, two expressions we obtained, they are very important. One, PDF of isotropic orientation f naught psi naught 1 by pi and PDF of an isotropic orientation psi 1 by pi c by cos square psi. Now, what is C? This is now the question. We need to understand about this C. What is the character of C? Well, the answer is hidden in this expression. If you read this expression very carefully, you will get the character of C. Let us use this hint. What will be the value of maximum value of this expression? Definitely the maximum value you will get at psi is equal to 0. Cos squared 0 is 1. So, in the denominator it becomes c square minus c square plus 1. So, that is basically 1 and there is pi, there is c. So, it becomes c by pi. What is the minimum value of this expression? If psi is equal to pi by 2. Cos square pi by 2 0. So, this whole term vanishes. In the numerator c, in the denominator c square. So, 1 c remains in the denominator and pi is already there. So, it becomes 1 by c into pi. Okay. What will be this two ratio? Maximum frequency divided by minimum frequency. C by pi 1 by c by pi. So, this will be c square. So, c becomes square root of f max by f minimum. Square root of the ratio of maximum frequency to minimum frequency, that is what is C. This ratio f max to f minimum, maximum frequency to minimum frequency, characterizes the anisotropy. So, C is a measure of anisotropy. Higher is the value of C, higher is the anisotropy. Can you guess what is the minimum value of C? Also, can you guess what is the maximum value of C? Let us think about isotropic orientation. In case of isotropic orientation, the relative frequencies are same. So, the frequencies are same. So, F max is equal to F minimum. What does that mean? This means C is equal to 1. For anisotropic orientation, F max is greater than F minimum. So, C must be greater than 1. Theoretically, C can be infinity. So, the minimum value of C is 1 and maximum theoretical value of C tends to infinity. So, it lies from 1 to infinity. So, that is the numerical character of C. Now, we would like to learn the behavior of PDF of anisotropic orientation. So, this is the behavior of PDF f psi. You remember what is f psi? 1 by pi C by C square minus C square minus 1 cos square psi. So, it is a function of psi. Psi is plotted along x axis, this is plotted along y axis. For different value of C, we obtain different curves. What is interesting to note is, let us see how it becomes C is equal to 1. When C is equal to 1, this is 1, here it is 1 minus 1 cos square psi. So, 1 minus 1 0. So, this whole term vanishes, here it is 1 minus 0 is 1, in the numerator it is 1, denominator is 1. So, it is 1. So, this becomes 1 by pi. That means, this point is equal to 1 by pi. So, you see at all angles this value is constant 1 by pi. When C is equal to 2, it becomes anisotropic. So, these curves from this becomes this 2, C is equal to 2 is this curve. When C is further higher 4, then you get this curve. Further high C is equal to 8, you get this one. So, as the measure of anisotropy C is increasing, the curve becomes steeper, indicating higher anisotropy. Right. So, this is the graphical behavior of this function. Now, we would like to discuss a very useful concept in fiber orientation. What happens is this: in the earlier case we have considered preferential direction as y axis. However, sometimes in practice preferential direction does not match y axis. It is inclined at an angle beta from y axis. Beta can be very small. However, the preferential direction is not the y axis, it stays at angle from the y axis. Suppose in this picture what is shown here, this is the x axis, this is the y axis, this is the fiber segment. The fiber segments makes an angle psi from y axis. However, y axis is not the preferential direction now, preferential direction is this direction. So, this preferential direction makes an angle beta from y axis and the fiber segment is making this angle from the preferential direction. Right. So, this beta becomes now important. This beta is lying from minus pi by 2 to pi by 2 and psi is now taking this form. Now, earlier what we have used? We have used the expression when the preferential direction was y axis, but now the preferential direction is changed from y axis. So, the PDF will be now valid for this angle 1 by pi c by c square minus 1 into cos square this angle. Okay. But we need to find out anisotropy with respect to psi, but this expression with respect to preferential direction. So, what will be the expression for anisotropy with respect to y axis or using angle psi? So, what we see is that in a more general case this becomes psi beta plus this. Beta is constant, right, because it is preferential directional angle. So, if we make the differentiation, this becomes 0 and this. So, this becomes 1. Because of this changeover of preferential direction not being the y axis, there is an angular disposition of the fiber segments, but the relative frequencies must be same, because the whole bunch of fibers were in a class. Because of this, now they all shifted to another class. So, the relative frequencies are remaining same. That means it is now this is the relative frequency, and after final disposition we get another function g psi is this, right. So, we are now interested to find out this function. So, what is your this? We have just now found out c by c squared minus c square minus 1 cos square psi minus beta into 1, right. So, we obtained 1 by pi c by c square minus 1 cos square minus beta. So, this is the most generalized expression of this angle. When preferential direction matches with y axis, that time beta is equal to 0. So, we obtain our earlier expression. In all other cases, when beta is not equal to 0, this becomes the expression for PDF of angle psi. What actually happens during measurement or during processing of fibers? We have no idea about this direction, whether during processing, suppose in carding, the preferential direction is little shifted from y axis. Being standing in front of the machine, we will have no idea about it. This might be happening because of many reasons. One obvious reason is because of some influences of the surrounding fibers. Another reason might be due to error. Error with handling of carded wave while measuring orientations. So, there could be some reasons because why the preferential direction will not be y axis. Suppose in case of yarn, think about yarn, the actual yarn axis is y axis, but preferential direction of fibers may not be y axis. The modal angle can be twist angle beta, where majority of the fibers are preferentially directed. This can also happen in yarn, but for measurement purpose we always take the value from y axis. So, we always get the value of psi, and we have no idea about this angle and this angle. So, ultimately we have to obtain the value of the function of psi. That is what we did. However, y axis is not now the preferential direction. Preferential direction is this one, and this is situated at an angle beta. So, we must show this influence, that is why it is psi minus beta. So, how do we come to know about this beta? When we handle with the data of fiber orientation in yarn or in carded web or in sliver. By analyzing the data, we will be able to know about this beta, right. So, this becomes a more generalized expression for fiber orientation, anisotropic fiber orientation. So, here C is basically the measure of anisotropy. Higher is the value of C, higher is the anisotropy, right. Now, we will discuss about one more problem associated with fiber orientation. The problem is something like that. Often we are interested to find out angle not from minus pi by 2 to pi by 2, but from 0 to pi by 2. So, actually the angles are lying from minus pi by 2 to pi by 2, but for some reason we will discuss about those circumstances when we need to do this, but we often need to do this theoretically. We need to find out the angles from 0 to pi by 2. That does not mean we will ignore the angles from minus pi by 2 to 0, that will be a mistake. We are not going to commit that mistake. We will consider those fibers, however, we will use some mathematical tools to convert those angles into positive angles. How we can do that? This we are going to discuss now. So, such angles where the lower limit is 0 and upper limit is pi by 2, we give a name, say non-oriented angle. Let us define this angle theta. This theta is the absolute value of psi. Then this theta ranges from 0 to pi by 2. So, by using this consideration, we can think about angles are positive angles 0 to pi by 2. So, let us now understand the distribution of this angle theta. So, distribution of non-oriented angles. Now, G of psi is equal to G of minus theta when psi is less than 0. So, when actually psi is negative, we use this expression, and when actual psi is positive, we have no problem. Including 0, right. So, now the angles are changed, it is no more psi, it is theta. So, we will have another probability density function that probability density function is related to theta. So, PDF of theta, we use u theta, right. So, how to obtain now this u theta? In order to obtain u theta, this must be true. The relative frequency of elementary class of non-oriented angle theta must be the sum of those two relative frequencies associated with psi. What does this mean? This means we are not going to ignore the angles, the negative angles. We will consider those negative angles, but in such a manner that the ultimate angle remains positive. So, this means the relative frequency is u theta d theta is the relative frequency. Why? Because u theta is the relative frequency density, d theta is the class width. We know that relative frequency divided by class width multiplied by class width remains relative frequency. So, this expression is the relative frequency. So, this is equal to g of minus theta plus g of plus theta, right. It must be d theta, it must be d theta. So, this is related to the negative value of psi, right, and this is related to the positive value of psi. Okay. So, u theta is equal to g of minus theta plus g of theta. Then in that case theta lies from 0 to pi by 2 close interval, right. Using our earlier expression, what we can find it out? U theta is equal to 1 by pi c by c square minus 1 cos square minus theta minus beta plus 1 by pi c by c square minus 1 cos square theta minus beta, right. Cos square minus theta minus beta is equal to cos square theta plus beta. So, if we write u theta is equal to 1 by pi c by 1 theta plus beta plus 1 by pi c by minus 1 theta minus beta. So, it becomes a long expression. How is the behavior of this expression? That we will now discuss, but then what we obtain is that it is possible to transform the negative angles into positive angles. This is often required to work theoretically. You will see in this particular case, when we will solve for Gagob's model and its correction, we will require this. So, in this manner we can obtain only the positive angles theta. So, although this equation looks long, however, it has immense significance in practice, because what happens in practice, then you need not to find out the negative angles. You can take the positive angles. By using this expression, you have considered both without neglecting anything. Right. Now, we would like to study the graphical behavior of this expression, how it will look like. You remember, we have already studied one graphical expression of f of psi, right. Will it be remain same for g theta, or it will be different? This is what we would like to learn. So, it is very simple. For different, suppose generally in a textile material, if the preferential direction is not y axis, it is deviating from y axis, then that angle must be constant. That preferential direction must be constant for that material. That means the angle beta must be constant for a given material, for a given yarn. If the yarn changes, then the beta will change, but within a yarn beta must be constant. So, by assuming a value of beta and also assuming a value of c, the c is also a constant for a given material. When the material changes, c will change. So, for given values of beta and c, if we change the value of theta from 0 to pi by 2, that is the interval of theta, we will obtain this value of u theta, and if we plot u theta along the y axis and theta along the x axis, we will obtain the graphical behavior of u theta. Exactly same we did to obtain this graph. U theta is along the y axis and theta is along the x axis. We start from 0, we start from pi by 2. So, let me write it again. What is u theta? 1 by pi c by c square minus 1 cos square theta plus beta plus 1 by pi c by minus 1 theta minus beta, right. Now, for isotropic orientation, C is equal to 1. So, in this expression if we substitute C is equal to 1, so this C square minus 1 becomes 0, here also C square minus 1 becomes 0, C is 1 1. So, 1 minus 0 is 1, in the numerator also 1, denominator also 1, here 1 minus 0 1, numerator 1, denominator 1. So, what we obtained? We obtained from here 1 by pi and here we obtained 1 by pi. So, u theta for isotropic orientation is 1 by pi, which is coming from here, because this expression is 1, this expression also 1. So, 1 by pi is coming from here. So, 2 by pi. Remember this. What is the value of u theta for isotropic orientation? The answer is 2 by pi, not 1 by pi. What is the value of f naught psi naught for isotropic orientation? The answer is 1 by pi. Psi naught and theta are different. Okay. Now, suppose C is equal to 4 and beta is equal to pi by 6. So, if we substitute C is equal to 4 and beta is equal to pi by 6 here, for different value of theta ranging from 0 to pi by 2, we will obtain different value of u theta. So, we obtained this graph. Similarly, if we substitute beta is equal to pi by 6 and C is equal to say 16, then for different value of theta we obtain different values of u theta. If we plot those values of u theta, then we obtain this curve. As we know, higher is the value of C, higher is the anisotropy. So, the curves of u theta becomes steeper when the distribution is more anisotropic, and this was the for isotropic orientation C is equal to 1. So, as we deviate from 1 to 4 to 16, the curves become steeper. That means, from isotropic to anisotropic orientation, as the anisotropy increases, we are obtaining the steeper curve. So, this is the behavior of u theta. So, we stop today's discussion here. The next class we will start from this one. Thank you for your attention.